Today we are going to do 7.5, which is solving exponential and logarithmic equations. So to start with, we are going to look at the property of equality for exponential equations, and this is really what we call the one-to-one property. So this is saying basically that if you have 3 to the x power and that is equal to 3 to the 5th power, then x is equal to 5 because you have like bases. That's the one-to-one property, making your exponents also equal. Okay, so if I have 2 to the 3x plus 1 equal to 2 to the x plus 4. Notice my bases are both 2. So I can use the one-to-one property and set my exponents, 3x plus 1 equal to x plus 4, and solve. So I would subtract my x. 3x minus x is 2x. I would subtract my 1. 4 minus 1 is 3. Divide by 2, and x is equal to 3 halves. Okay? So remember that if you don't have like bases to start with, you need to make like bases, which we have done before in chapter 6. So if you have, for our first example, 100 raised to the 7x plus 1 power equal to 1000 raised to the 3x minus 2 power. 100 and 1000 are not like bases, but I can manipulate both of these to have a base of 10. So 100 is the same as 10 squared, and that is raised to the 7x plus 1 power. And 1000 is the same as 10 cubed, and that is raised to the 3x minus 2 power. So if you remember your properties of exponents, when you have a power raised to a power, you multiply those. So this becomes 10 to the 14x plus 2 power because you distribute, equal to 10 to the 9x minus 6 power because you distribute there. Now I have like bases. Because my bases are equal, I can use the one-to-one property to say that 14x plus 2 is equal to 9x minus 6. Then I could subtract my 9x from the 14x, and I can subtract 2 in the same step, and that is going to give me 14 minus 9 is going to give me 5x equal to negative 8. So when I divide by 5, x is equal to negative 8 fifths. Okay, in our second example, we have 4 to the 2x plus 2 power equal to 64 to the x minus 2 power. Now, I can manipulate 64 to have a base of 4 because 64 is the same as 4 cubed. So I can say that's 4 cubed raised to the x minus 2 power and do the same steps that I did here by multiplying 3 times x minus 2. So I have 4 to the 2x plus 2 power equals 4 to the 3x minus 6 power. I can use my one-to-one property to set 2x plus 2 equal to 3x minus 6. And then for me to solve, you can subtract your 3x or subtract your 2x and move it over to the right. I'm going to do that to keep a positive x value. So if I'm moving my 2x to the right, I want to move that negative 6 over to the left by adding 6. And so that leaves me with 8 equals x, or x equals 8 rewritten. Okay, so what if the bases are not the same and you cannot get like bases? Then you're going to rewrite the equation in logarithmic form and solve for x. So if you remember in 7.3, we did log base solution equals exponent. So that is what we're going to be using. So if I have my first example, 4 to the x equals 11. Notice I cannot manipulate a 4 or 11 to have like bases. Also notice that in the previous two examples you have exponents on both sides, Here I only have an exponent on one side. This will also be a key factor of being able to use your log-based solution equals exponent form. So if I am looking at 4 to the x equals 11, then when I rewrite it, I've got log, my base is 4, my solution is 11, and that is equal to x. Okay, so what I can do is I can use the inspire, and if I have log base 4 of 11, then if I look next to the 1 on your calculator, there's a 10 to the x power, but in your calculator it's gray. You have log, so you can hit control and then that button with log, and that will prompt you to be able to put a base of 4 and then your 11. So I'm going to round that to 3 decimal places, so x is equal to 1.730 because the 7 rounds the 9 up, so 1.730. Okay, so then for our second example, we have 6 to the 3x plus 1 equals 8. Again, you cannot manipulate 6 to have a base of anything, and 8 can reduce to a 2, but 6 cannot. So we're going to rewrite that with your log. Your base is 6, my solution is 8, and my exponent is 3x plus 1. Now here we would have to actually solve for x, but we're going to get the decimal for log base 6 of 8 first. So I'm going to take my control log base 6 of 8, and that's going to give me 1.161 equal to 3x plus 1. So then from there I can subtract my 1. 1.161 minus 1 is just 0.161, and that is equal to 3x. Then I can divide both sides by 3. So that divided by 3 is going to leave me with x equals 0.054. Okay, so what if instead of a base of a number, you have a base of e? That is when you're going to use the natural log when you rewrite it instead of just the common log. Okay, not the common log, but log. So remember that the natural log of e is equal to 1. So if I start with my first example, I have e to the x power minus 2 equals 8. So I want to isolate my base, e to the x, so I would add 2. E to the x is equal to 8 plus 2 is 10. So when I rewrite it, it's going to be, if I have my log base solution equals exponent, and I have an e as my base, I'm going to do a natural log. Now I'm going to have natural log of e, my solution is 10, equal to my exponent. Now you don't have to write that e, because anytime you see a natural log, it's understood that you're going to have a base of e. So if I use my calculator, I can just do, if I look at e to the x, control, that button gives me my natural log, so I'm just finding the natural log of 10. And so x is equal to 2.303. Okay. And then our second example is if we have 4e to the negative 0.3x minus 7 equals 13. Again, your goal is to get whatever is being raised to the exponent by itself. So I want that by itself. So I would add 7 first, so 4e to the negative 0.3x equals 20. Divide by 4. E to the negative 0.3x, 20 divided by 4 is 5. Now the base is by itself, and you can rewrite it. I'm going to take the natural log. Remember, the natural log has a base of e, so if you want to write it, you can, but I'm not going to. Natural log, base of e of 5 equals negative 0.3x. So we can use the calculator. if you do the natural log of 5, that gives you 1.609 equal to negative 0.3x. So I can take that 1.609 and divide it by negative 0.3. And that's going to give me x equals negative 5.363. Okay? So then we can move on, and we're going to solve our exponential equations. So when you solve for your exponential equations, don't forget to check for extraneous solutions. So all of these x values that we're finding, you can plug back into the original and check to see if you're getting the right answer. So don't forget that you cannot take the log of 0 or the log of a negative number. That is 2 specific rules we have for logarithms. Okay, so our first example is if we have 4 to the 2x minus 1 equals 8 to the x plus 2. Now here is where, remember I said if you have exponents on both sides, that more than likely means you can manipulate these. While a 4 cannot, an 8 cannot go down to a 4, but they can both be a base of 2. So 4 is the same as 2 squared raised to the 2x minus 1 power, and 8 is the same as 2 cubed raised to the x plus 2 power. So when I simplify this, I have 2 to the 4x minus 2 equal to 2 to the 3x plus 6. Now I've got my one-to-one property. I can set 4x minus 2 equal to 3x plus 6. I can subtract my 3x, and in the same step I can add the 2. So that leaves me with x equals 8. Now to check this, you can check it with your Inspire or the scientific calculator. If you're doing it in the Inspire, you can take 8, control var x, enter, and then you have 4 raised to the 2x minus 1, so the left side is equal to that value, and then 8 raised to the x plus 2 is equal to the same exact value. So if you get the same values, you know it's true. X equals 8 is a valid solution. Okay, and then my second example, I have 3 to the x plus 3 power equals 5. Okay, so I do not have exponents on both sides. I cannot manipulate the 5 to become a 3. So this is where we're going to rewrite using the log base solution equals exponent. Okay, so if I do that, then when I rewrite it, I have log base 3, my solution is 5, is equal to x plus 3. So I can go to my calculator, and I can type in, let me get it to where you can see it, log base 3 of 5, and that's going to give you 1.465 equals x plus 3. Now you take that 1.465 and subtract 3, and x is equal to negative 1.535. Okay. So then, for our third example, we have 10 to the 3x minus 1 plus 3 equals 3. So we are going to isolate the base that's being raised to the exponent by subtracting 3. So then that leaves me with 10 to the 3x minus 1. 3 minus 3 would equal 0. Okay, when I go to rewrite this, I'm taking the log base 10, which is just a common log. Log 10 of 0 equals 3x minus 1. But remember that our rule, you cannot take the log of 0, and this is taking the log of 0, so we would stop there and say that there is no solution. Okay, so then our next example is if I have 7 to the 9x power plus 3 equals 15. I need my base, that's raised to the exponent by itself, so I would subtract 3. So 7 to the 9x power is equal to 12. Then I need to rewrite it, so log base 7 of 12 is equal to 9x. Log base 7 of 12, if you type that in your calculator, log base 7 of 12 gives you 1.277. 1.277 equals 9x. So when you take that, 1.277, I need to divide by 9, and that gives me 0.142. X equals 0.142. Now all of these you should be storing in your calculator and typing them in just to make sure that they are not extraneous. Now with example 5, we have negative 14 plus 3e to the x power equals 1. So I want my base of e by itself. So I'm going to add 14 to both sides. Leaves me 3e to the x power equals 15. Then I can divide by 3. E to the x is equal to 5. So when I rewrite this, I have a base of e. So instead of a log, I'm going to use natural log. Base e of 5 is equal to x. So if you type natural log of 5 in your calculator, x is equal to 1.609. Okay, and then our last one for this section, if we have 2/3 e to the 2x power minus 6 equals negative 3. So I'm going to get e to the 2x by itself by first adding 6. So I have 2/3 e to the 2x power negative 3. Now plus 6 is going to give me a positive 3. And then remember, to get rid of a fraction, we never divide by fractions. We multiply by the reciprocal. So e to the 2x power is equal to 9/2. Now the base is by itself. We can rewrite natural log of e, base e of 9/2 equals 2x. So when I do the natural log of 9/2, you can either write it like that, your calculator will automatically put it in a fraction, or you can do control divide, and that will give you the fraction template to enter in your 9/2 as a fraction. Still gives you the same value, 1.504 equals 2x. Then you divide both sides by 2, so 1.504 divided by 2, x is equal to 0.752. And again, you need to check all of those for extraneous solutions when you're doing your homework. Okay? Now, we're going to do logarithmic equations. So notice that I started with exponential and I rewrote it to logarithmic. Here, I will be starting with logarithmic and I will be rewriting as exponential. So if I look at my first example, I have log base 2 of x minus 6, and that is equal to 5. So remember, you cannot take the log of 0 or a negative number. So if I have this, I would try to isolate my logarithmic part first. I already have it isolated, so I rewrite it. Remember, it's log base solution equals exponent. So when I rewrite it in exponential form, I'm going to have a base of 2, 5 is my exponent, and that is equal to x minus 6. So 2 to the 5th power is 32. 32 is equal to x minus 6. To solve for x, you would add 6. 32 plus 6 makes x equal to 38. So when you are checking your logarithmic functions, when you have 38, store it for x. I'm going to type the left side log base 2 of x minus 6. It gives me 5, which is what my original equation is, so I know that's an answer. Okay, my second example is if I have 2 log base 6 of 2x minus 5 equals 4. So if I want log by itself, I need to divide both sides by 2. That leaves me with log base 6. Notice that that base never changes. Neither does the 2x minus 5. You're only getting rid of the 2 as the coefficient. And so 4 divided by 2 is 2. So when I rewrite it, my base is 6. I raise that to the second power, and that is equal to 2x minus 5. So 6 squared is 36. 36 equals 2x minus 5. I would add the 5. 36 plus 5 is 41. So when I divide by 2, x is equal to 41 halves. Okay, so when I type this in the calculator, I do control divide, 41 halves, store for x, and I have 2 times my log base 6 of 2x minus 5. That is equal to 4. So x equals 41 halves is my answer. Okay, so then I'm going to split this. I still have 2 other examples. If I look at example 3, I have log base 3 of 3x plus log base 3 of x equals 7. Now if you remember from 7.4, the properties of exponents, when I see a plus sign, that means I'm multiplying. So I'm multiplying 3x times x. So if I do 3x times x, that gives me log 3 of 3x squared. That is equal to 7. Now that I have condensed it, so anytime you have 2 logarithmic functions, not functions, but 2 logs in one equation, you need to condense. So I've condensed it. Now I can rewrite it. 3 to the 7th power equals 3x squared. 3 to the 7th power is 2,187, and that's equal to 3x squared. So I will divide both sides by 3. That makes x squared equal to 729. When I square root both sides, I get x equals plus or minus 27. So do not forget that when you take the square root, you have a plus or minus. So this is telling me I have x equals a positive 27 and x equals a negative 27. So I have to check both of these. So when I check these in my calculator, I have 27 store for x. And so I have log base 3 of 3x plus log base 3 of x. That gives me 7. So x equals 27 is good. Now when I do negative 27, when I plug this in, 3 times the negative 27 is going to give me a negative value, and I cannot take the log of a negative. So for you to see what that looks like in the calculator, if I have negative 27 store for x, and I go back and type the same thing, it's going to give me an error issue. There's no real calculation. That is because you cannot take the log of a negative. So whether I plugged in the negative here and the negative here, either way for your original, you cannot take the log of a negative, so there is an extraneous solution. You just mark through it. Okay. So this next one I'm going to put up here, example 4. I have log of 5x plus log of x minus 1 plus 2 equals 4. So again, I have two logs, I need to condense them. A plus means I multiply, so I multiply 5x times x minus 1. So if you need to write the 5x times x minus 1, and I can also subtract the 2, and so that's equal to 2. If you need to write it like this before you multiply, you can. This just gives me 5x squared minus 5x equal to 2. Now notice I don't have a base written. If I don't have a base written, that means it's a common log. I have a base of 10. So when I rewrite it, I have 10 squared equals 5x squared minus 5x. 10 squared is 100. 5x squared minus 5x. So anytime you have x squared x in a constant, your goal is to get it equal to 0 and factor. So I'm actually going to subtract the 100 so that I leave a positive x squared. So I have 5x squared minus 5x minus 100 equals 0. Okay, if you notice you have a 5, 5, and a negative 100, I can take a 5 out as a GCF, and that leaves me with x squared minus x minus 20 equal to 0. I want factors of a negative 20 to give me a negative 1. So factors of negative 20, you have 1 and 20, 2 and 10, 4 and 5. So 4 and a negative 5 will give me the negative 1 that I want. Set it equal to 0. I do not need to set my GCF equal to 0, just the terms with the x value. So x plus 4 equals 0 and x minus 5 equals 0. Gives me x equals negative 4 and x equals positive 5. So when I check these, I'm going to take negative 4, store for x, and I'm going to have my log, I don't need to put the 10, log of 5x plus my log of x minus 1 plus 2. Oh. Okay, so when I get that negative 4, it's extraneous because I got a non-real calculation. So then take 5, store for x, go back up. It gives me the 4 that I originally started with, so x equals 5 is my solution. So again, that negative 4, when I plug that in, 5 times negative 4 would give me a negative 20. I cannot take the log of a negative. That's another reason it's extraneous, and that's why you have a non-real calculation. Okay, so now we're going to look at a few more examples. If I have, I think this is example 5, if I have log of 8x equals 3 minus log of x minus 20, notice I have two logs again. If that is the case, you want to condense them. Well, if they're on opposite sides, then that means I need to get all of my logs on one side. If it's a negative, I'm going to add it for the other side. So I'm going to have log of 8x plus log of x minus 20 equals 3. Now I can see them on one side. It has a plus, so I'm multiplying 8x times x minus 20. So 8x times x is 8x squared, and 8x times negative 20 is negative 160, and that is equal to 3. So then what I'm going to do is I'm going to take my base, which is a 10. 10 cubed is equal to 8x squared minus 160x. That means 8x squared minus 160x is equal to 1,000. Again, I have x squared, x, and a constant, so I want to subtract that 1,000, get it equal to 0. So 8x squared minus 160x minus 1,000 is equal to 0. I can factor out an 8 as a GCF, and that leaves me with x squared minus 20x minus 125 equal to 0. So now you want factors of a negative 125 to give me a negative 20. And so that will be x minus 25 and x plus 5. So if I set x minus 25 equal to 0 and x plus 5 equal to 0, then that leaves me with x equals 25 and x equals negative 5. So again, I already know if I plug in this negative to 8x, I'm going to get a negative 40. I know that's extraneous. So if I'm thinking of that way, then I can already assume that's extraneous, and I just have to check 25, store for x, and I do my original equation where I have log, I'm going to type the 10, of 8x. That gives me that value. So the left side is 2.30103. The right side, 3 minus, do your control log, 10, x minus 20, gives me the same value, so x equals 25 is good. Okay, so now I've got my sixth example where I have the natural log of 7x minus 4 equals the natural log of 2x plus 11. This is a case where if you have a natural log or a log of the same base on both sides, and this is all it looks like, so whether it looks like natural log, or even if I have log base 3 of 7x minus 4 equals log base 3 of 2x plus 11. Either way, this is the same one-to-one property, meaning if these are both natural log or both log of the same base, then this 7x minus 4 is equal to the 2x plus 11. So then I just need to subtract my 2x, add your 4. That leaves me with 5x equals 15, divide by 5, x is equal to 3. Now you could still plug that in and check, it is going to be good. Okay? So anytime it looks like this, that is the one-to-one property. You just set those two equal to each other. Okay? And so our next example we have, let's say example 7, is if we have natural log of x equal 2. And this is just reminding you that if you start with a natural log, you have a base of e. So when I go to rewrite this, my base is an e, so e squared equals x. So again, if I start with logarithmic, I rewrite it in exponential. If I start in exponential, I rewrite it in logarithmic form. So here, e squared, I just type in my calculator, e squared gives me 7.389. You would still plug that in and check, but I am good. So then, say that next example, we have natural log of 2 minus 3x plus 4 equals 7. I want the natural log by itself, so I'm going to subtract my 4. Natural log of 2 minus 3x, 7 minus 4 is 3. I've got my natural log by itself, so I rewrite it. Base of e, e to the third power equals 2 minus 3x. So e to the third power in your calculator is 20.086. I would subtract my 2. So 20 minus 2 is 18.086. That's equal to negative 3x. Divide by negative 3. X is equal to negative 6.029. Again, plug it in. That will work. Okay, so our next example, we have natural log of 4x minus natural log of 3 equals 6. I have two natural logs, so remember you have to condense. If I'm condensing and I have a minus, that means I am dividing, so I'm going to create a fraction. Natural log of 4x over 3 is equal to 6. So when I rewrite it, I have e to the 6th power equals 4x over 3. Now, e to the 6th power in your calculator is going to give you 403.429. So that is equal to 4x over 3. So to solve for x, I'm going to multiply both sides by 3. And that gives me 4x equals 1,210.29. Divide by 4. And x equals 302.572. Okay, and then for my last one, you have natural log of negative 3x plus 1 in parentheses equals natural log of 4x plus 4. Now you have to be careful with this because if it is written closely, then some people might mistake 4x plus 4 as the entire connection with your natural log. But notice that this had parentheses. It will have parentheses if it has more than two terms. So here, this natural log of 4x is separate from the plus 4. It is not natural log of 4x plus 4. So if I have two natural logs, that means I need to move it over. I'm going to subtract it. So I have natural log of negative 3x plus 1 minus natural log of 4x equal to your 4. Again, you have two logs you're trying to condense. Minus means you are dividing, so you're taking the natural log of negative 3x plus 1 divided by 4x, and that is equal to 4. So when I rewrite this, I have a base of e raised to the 4th power, and that's equal to the negative 3x plus 1 over 4x. So e to the 4th power in your calculator will round to 54.598. That is equal to the negative 3x plus 1 divided by 4x. Now when you go to solve this, you have an x in the numerator and x in the denominator. If you just had a 4, you would multiply both sides by 4. So I'm going to do the same step. I just multiply both sides by 4x. And so that's going to give me 218.392x equals negative 3x plus 1. Then you have an x on the left and an x on the right. I need to combine like terms, so I'm going to add my 3x. When I add 3x, that's going to give me 221.392x equal to 1. Now I need x by itself, so I'm going to divide both sides by that 221.392. So x is equal to 0.005. you have a quiz over this next class. Make sure that you are using your properties of logarithmic properties whenever you have two logs or natural logs in one equation. If you start with a logarithmic, you end up rewriting it in exponential. If you start with exponential, remember you rewrite it in logarithmic. So if you have any questions, let me know. Come see me before or after school. And that is it for 7.5.